Now, one of the benefits of being the Salvajor guy is when it comes time to get rid of food waste, you can get rid of food waste out of an operation in two ways. It'll go through the pipes and out into the infrastructure where you're paying taxes and being metered and all that other stuff. It is the least labor intensive way. It is the most convenient way to remove food waste from an operation. The other way, instead of going out the pipes that you can get it out of your operation, is you can get it out the door. And that typically means you're taking food and you're putting it into either a pulper, a collector, which we provide, or you're using that pre-rinse with a scrap basket. What you're doing there is you're simply taking that food waste and you're putting it into a 55-gallon drum or whatever plastic bag you're putting it into, and then you are lifting that and carting that out to your dumpster, which then is being hauled away and put into the landfill. So two different ways to get food waste out of an operation, okay? Being on this engineering meeting, I'm assuming we're all designing or consultative in some way with our clients. So I just wanted to give you that tidbit so you can have just a better understanding of food waste and how it really impacts an operation. You have to get it out of there. You have to get clean dishes. That's really kind of the key. The second thing that I want to talk about is our two-handed scrapping systems and how they factor in to your design. And this is kind of the meat and potatoes of what I wanted to talk about is responsible design as it pertains to food waste and handling food waste and working within the fiscal budget that's given to you by either the operator or the architect, or two, the budget of space that you're allowed, okay? Once or twice in the history of architects and kitchen equipment designers, there's been a debate about space. Is that fair to say? And one of the things that I feel is really important to let people know, the Salvajor two-handed scrapping systems have been around forever, whether it's the collector or the disposer. We're getting food waste out of an operation. But two-handed scrapping is more important today than ever before. I'm going to go over some of those things with you, to give you some quick little tidbits. If you have additional questions and comments, I'll be happy to follow up with you. But one of the things I like to help people know and understand, as we as a society and as an industry have gotten better about managing the sustainability of our operations. Okay, a 64-inch dish machine used to use about 400 gallons of water an hour. Well, now those same 64-inch dish machines use about 100 to 120. Some ware-washing manufacturers are getting sub 100 at this point, right? Fair to say? So when you're looking at getting dishes properly scrapped and cleaned, when you're trying to minimize rejects, you really want to look at a two-handed scrapping system. We're recirculating water, we're minimizing the amount of labor you need to have in your operation, and it's harder and harder for operators to find people to work. Labor is not easy to find right now. These things are exacerbating the need for a two-handed scrapping system. You're 2 to 3 times faster, and you're also more effective at getting the food waste off of the dishes. So when you're using less water to get dishes clean in the dish machine, you have to scrap better up front. This will minimize rejects. Putting these dishes back through again is expensive. It's more labor, it's more water, it's more heating of water, it's more chemicals being used. And we're trying to save on those things. And that's what the two-handed scrapping system does. The other thing that I kind of wanted to make you aware of relative to the two-handed scrapping system that might be a little bit newer is more about saving on space and saving on dollars, okay? You could go from an operation that has maybe a 66 Okay, so that's a 44-inch dish machine with a pre-wash on the front of it. Okay, and by no means am I saying you have to have either a two-hand scrapping system or a pre-wash. What I'm trying to do is educate you and inform you a little bit on some design options to be considered. If you can remove that 22-inch pre-wash, that's about $22,000 to $25,000 list. You could put my scrapping system in front of that, and you're going to get dishes better scrapped. You're going to recirculate water, and you're only going to spend maybe $12,000 list at most. Okay. So now you've picked up another, I don't know, couple feet in the soiled dish area, and you saved a significant amount of money on somebody that's already investing tens of thousands of dollars into their dish room. So you can kind of look at these things, and then you can take it a little bit further. Well, Jim, maybe now what I can do is I can get rid of that pre-wash, go with a scrapping system, and instead of having a 44, now I can switch gears and say, okay, let's go back to a 2-tank machine, which is a 64-inch dish machine. So now you got the 2 tanks. You're going to get better, cleaner dishes. You're going to get better operation, and then you can have that system in front of it. So now you're kind of being a resource and a solution provider for the customer. And that's kind of what I'm trying to help the engineers and the consultative folks that are out there to really help you understand the how and whys, to talk about Salvajor as a product and as a solution for the overall warewashing or the overall dish pit design. Anytime we can save on space, anytime we can save on dollars, it doesn't hurt to educate the customer. The better you're prepared to talk about and discuss the how and why of the systems, the better off you're going to be. So one thing I want to kind of delineate now on our 2-hand scrapping system, since I'm getting low on time already, is we have the collector systems, which is a 2-handed scrapping system where the basket is being put, we're using 2 gallons of water per minute. You're getting 30 gallons per minute of flush or force from our machine. And basically what that's doing is it's washing all the soluble food waste down and out into the infrastructure. And that leaves you with a basket that you can take out and dump and then run out to the dumpsters. Now, the benefit to only using 2 gallons of water per minute but getting 30 gallons of flush is we're reducing the amount of food waste that you're putting out into the landfills, or having to pay to cart away, or having to allocate space for dumpsters, or having to allocate pickups. Maybe we can minimize the amount of pickups by having less food waste to go out there. Now what you can do is talk a little bit about how we're reducing that food waste, and that food waste is overall a reduction of about 53%. A 53% reduction in food waste is compelling to an operator. It makes a lot of sense. And to kind of just maybe help people understand the food waste, the soluble food waste that we're talking about, that 53%, think of refried beans and sauces and jellos and pastas and things like that. If you throw half of an apple in there, you're not going to get a 53% reduction of food waste. We're not dehydrating anything or pulping anything. We're simply using that water to kind of pull that away and let it go. So that's kind of what I wanted to make sure we knew about on the collector systems. I'm going to try to share my screen and share a quick little video that you'll want to go check out on YouTube, Salvajor's YouTube. It is the How It Works Salvajor Disposer System. This is where we're using 2 hands, but we're grinding it out. And this will kind of show you how it operates and how it works. Please don't forget to tag it, hashtag Salvajor Strong. Thank you all for your support out there. I can't wait to get out and see you. Apologies if I butcher this, but we'll get her done here somehow.
Welcome to Salvajor. This video details how our disposer systems work for the Scrapmaster and Pot and Pan Scrapmaster. Our Trough Veyor models are similar in operation. Let's get started. When the system is first turned on, hot and cold water pass through a water blender set at 107 degrees Fahrenheit. Blended water enters the tank reservoir at the rate of 5 gallons per minute. Cold water is introduced directly into the disposer grind chamber at the rate of 2 gallons per minute. The water level in the tank reservoir rises until it overflows into the disposer at the rate of 5 gallons per minute. When the tank reservoir holds sufficient water, the system pump begins circulating water through the gusher tube. As dishes are passed through the water plume, they are scrapped and pre-rinsed at the same time. Food waste is flushed directly into the scrap basin and carried by the water toward the revolving separator discs. Water falls through the discs and returns to the tank reservoir. The waste is carried over the discs and into the disposer for grinding. And that's a brief overview of how our disposer systems work.